Welcome to Backup Exec 2012, Agent for Microsoft SQL Server. If you're following along in the book, we're in Lesson 3. In this lesson, we'll give you an overview of how SQL works. I do not intend to make anyone a database administrator, but you have to understand how SQL works so that you understand how to back it up and why you have to back it up the way you do. So we'll go over how SQL works at a very high level, and then we'll go into the agent for SQL Server and how it is communicating with SQL in order to back up that data. We'll look at creating a backup for SQL and the process that you need to go through, what's included in that backup. Then we'll take a look at restoring SQL, and this is at a database level. If you want to restore the entire SQL Server, the best option for that is simplified disaster recovery. So on the restore side, we'll talk about restoring databases and redirecting databases. Let's start with the fundamentals of SQL itself. SQL can be installed many times on the same host. These are known as instances. You break up SQL instances so that you break up the processing of different databases. So in the example that we have in this screenshot, we have one SQL server that's running 2 instances of SQL with a total of 5 databases that are production databases. Every instance of SQL has one database known as master that knows about the configuration of all the other databases. When we talk about backing up and restoring SQL, you must make sure that you're backing up master, model, and MSDB. These are our configuration databases that house information about all of the production databases that are on that SQL server. So backing up just the production database will back up the database, but it won't let you do a full disaster recovery. TempDB is a database that depends on how the production databases are configured that may or may not have a great deal of activity. So TempDB may be a temporary storage location for your production databases. If you're not sure, the best practice is to go ahead and get TempDB as well. The Backup Exec agent for Microsoft SQL is licensed per application per server. So in the example that we have on this screen, since we have one host, you would have to have a license for the application, the agent for applications and databases for SQL, one license for this entire host. If this host also housed Exchange, you would have to have another license for Exchange. So the agents are licensed per application per host. Understanding that Backup Exec understands this data structure, that master is the configuration of all of the production databases, and that it must be backed up in order to do a full recovery of SQL. The way SQL databases get their speed is a couple of different things. You have a database that's also known as a device in SQL terminology, that if you're looking at it at a file level will have an extension of MDF. That's the database. This is usually housed on a volume that's all that it houses is the database. The other portion of the SQL database is the transaction log. The transaction log is where the applications are actually writing data in. Eventually that will get committed to the database, but databases get their speed by writing to the transaction log. The transaction log, if you're looking at it at a file level, has an LDF extension. According to SQL best practices, the database and the transaction log should be installed on completely separate volumes. Not all SQL databases are installed that way, but very large SQL databases certainly are. Applications that access the SQL database, such as the Backup Exec console that runs on a SQL database, will write anything that they're doing into the transaction log. So when you create a job in Backup Exec, you're truly writing into the transaction log. At some point, that will get committed to the database. In SQL, you need to make sure that you are backing up both sides of this. You have to touch the database and touch the transaction log. Different databases can be configured in different methodologies, and we'll go through some of those methodologies for SQL, that the transaction log becomes less important in some instances. When the database gets very, very large, a database administrator might break that database up into smaller chunks, so the MDF is actually a whole group of secondary data files that will have an NDF extension. Backup Exec does not show you the file level at all. Backup Exec, when you use the agent for Microsoft SQL, will show you the database icon, the little drum icon for the database. The agent is responsible for finding all of the pieces of the database, if there are NDFs available, and for dealing with the transaction log regardless of where the transaction log is located. So Backup Exec does not show you that these are installed on separate volumes. It does not show you the file level names. But you have to understand that when you back up SQL, you must back up the transaction log and the database in order to do a full recovery of SQL. SQL also allows you to set up standby databases. This is a function of SQL if we took Backup Exec out of the picture. This is set up for high availability. Usually, large production SQL databases have to do with billing, so they're the money coming in and going out of your organization. They have to do with your customers. These are mission critical databases. So SQL allows you to do something called log shipping. And you'll notice in the graphic here that the data disk and the log disk are two different volumes. That is a SQL best practice. If you set up a standby database in SQL, what that means is that I'm using SQL itself to package up the transaction log and duplicate that to a different location. So there is essentially a mirror of your SQL server. And if the primary SQL server were to fail or be brought down for maintenance, you could bring up the secondary copy of it so that your users would be accessing the database through the secondary copy instead of the primary. So automatic log shipping copies transaction logs to keep two different databases synchronized. Backup Exec understands this, and the SQL agent can put the database into standby mode so that it can do the transaction log backup without interrupting the production server's functionality. So the agent understands this whole business of log shipping and that it can back up the secondary machine so that it doesn't interrupt the primary machine and the user's access to the primary database. The agent for Microsoft SQL provides a great deal of support for backing up SQL Server. SQL Server is a mission-critical server. Backup Exec understands that. So the agent allows us to back up the database, the transaction log, and do backups of just the things that changed in the database, the deltas, the things that changed in the database. We automate the restore if you have to restore multiple databases. In SQL, if you have to restore multiple databases, you must restore the master database first, restart the SQL services, and then restore your production databases. The Backup Exec agent understands that, and it will automate this process for you so that it will just restore master, restart the services, and kick off the other restores. In older versions of Backup Exec, there was a checkbox that you had to mark to get this automation function. In Backup Exec 2012, it simply happens. We also support simplified disaster recovery, meaning that you can back up all of the critical pieces of this server. The C drive, which houses the SQL binaries, the executables that run the SQL services, and system state, which is the registry that shows how SQL was installed. So I can do a simplified disaster recovery of the SQL server as a whole. And then if I choose to, I can restore the databases after that server has been recovered. So we support simplified disaster recovery in a simple mode, meaning bringing back just the OS, or you can bring back the OS and all the data at the same time. It's usually faster to do it in two separate steps because there's a reboot needed between. We allow you to, the agent allows you to restore SQL databases to alternate locations. SQL databases traditionally are very tied to the host name of the SQL server. So the agent takes that into the redirect and allows you to redirect and adjust the host names appropriately. The agent for Microsoft SQL also allows you to back up the databases while they're up and running. So the SQL services are up and running, the databases are fully functional and can be accessed by the users for the entire duration of the backup. We can back up the standby database. The agent also supports the various types of database consistency checks that SQL supports. We'll go through those later. And I can set up consistency checks based on which database I'm backing up if you select it at a database level. So you can do different types of consistency checks for different databases. The full, bulk logged, and simple recovery models are SQL recovery models if you took Backup Exec out of the picture. Backup Exec understands these different recovery models for SQL and backs up and restores them appropriately based on the SQL configuration. So if SQL is configured for a simple recovery model, the agent understands that and backs it up and restores it appropriately. If you're running SQL Server 2005 or later, the agent for SQL also allows you to do database snapshots. SQL has its own snapshot provider that allows us to take a snapshot of the database and then back up the snapshot. SQL itself also has a new function, or relatively new function, called copy backups that do not reset anything. So I can back up the database without resetting the transaction logs. So it doesn't interrupt a typical backup rotation. Backup Exec, the agent allows you to maintain your replication settings during redirected restores. So if my primary server was replicating to a secondary server and I redirect those databases to yet a third server, it will still replicate back. SQL also supports verify-only restore jobs. This is relatively new to SQL. Usually these databases are fairly large, and restoring them takes a great deal of time, not to mention resources and drive space. But these are mission-critical databases, so often people will have trouble restoring them because they do take up so much space and time. SQL now supports verify-only, meaning that it will look at the backup and say, is everything in the backup correct? So that if I truly did restore this data, it would come back properly. But you're not restoring data. You're simply verifying that the database placement exists, that master can house the data, and that everything that you need is in the backups. So Backup Exec allows you to do these verify-only restores as well. You can back up with checksum. This is a short way of doing a DBCC. And SQL also now allows you to continue if restore job has problems. In older versions of SQL, if you did a full backup and transaction log backups, and on the restore side you got the transaction log restores out of order, the SQL services would stop and never come back up again. And the only way to make SQL work was to start your entire process all over again, and this could be many hours of restores. So newer versions of SQL will allow you to continue, and the services will run even if the restore job has errors, depending upon what the errors are. If you're running SQL Server 2008, Enterprise Edition or later, you can use compression to make the databases smaller. Now this is not a disk compression in Windows, this is SQL compression. And Backup Exec agent understands that and can back up and restore databases that have been compressed using SQL compression. The requirements for using the Backup Exec SQL agent: Backup Exec must have access rights to read the registry keys on the server where SQL is installed. It must have access to the SQL installation, meaning it must have an account that has DB Data Reader, but also DB Data Writer to do restores into SQL. SQL can be installed in two different methods. It can be installed in Windows mode, meaning it's using Active Directory usernames and passwords to access SQL, or it can be installed in SQL mode. Depending on how SQL was installed, you may have to provide unique credentials to Backup Exec to allow it to access that SQL database, where it is not able to use its standard Windows account to access SQL. You just simply need to make sure that Backup Exec can access, both for read and write, anything that you wish to back up or recover in SQL. The agent has to be installed on the SQL server. That's true always. Any data that you want to back up, the agent has to be on the data that you back it up. And the credentials have to be appropriate for DB Data Reader, DB Data Writer. In SQL, that's known as a system administrator role, but you could also provide security at a different level, provided your DBA understood that. To use the logon accounts for SQL, when you choose to back up a SQL server, in this case it's MBES, what you'll see is the little SQL Server instances. So I'll see the little drum database icon. If I click on Test Credentials, you'll see the different SQL instances. You may have to provide separate credentials to back up these SQL databases. So on the Test Credentials screen, you have one set of credentials to back up the volumes, C and E in this case, and another set of credentials that are used to back up SQL itself. What's very interesting about this agent is that SQL may be installed so that the database is on the E drive. In this backup, when I back up the E drive, Backup Exec will back up everything on E except SQL. And then as we come down the backup and access the SQL databases, we'll back up only the SQL databases regardless of where they live. So in this case they live on E. So the SQL agent allows you to back up the databases separately from the file system, which is allowing you to create snapshots and follow all the rules for how SQL needs to be backed up and restored. You see here a list of all of the different versions of SQL Server that the Backup Exec agent supports. You'll notice that SQL 2000 is not on this list. To install the Backup Exec agent for Microsoft SQL Server, you have to go to the Agent for Applications and Databases. I need to have a license key for every server that is running SQL. So if you have multiple SQL servers, that you would have to have multiple agents for applications and databases. When you purchase the application for the agent for applications and databases, you have also purchased the right to put the agent for Windows on any SQL server that you are backing up. So the agent for applications and databases includes the agent for Windows that needs to be installed on this SQL server. By default, Backup Exec will use snapshots to back up the database. So this is using the Advanced Open File option to create snapshots of the database. SQL allows you to revert the database to a snapshot. So Backup Exec will also allow you to revert the database to a snapshot. When a backup job is submitted that uses snapshot technology, Backup Exec is truly calling the Volume Shadow Copy Service, or VSS. VSS will then use the SQL provider to quiesce the database. This is where it's momentarily suspending write activity so that there's nothing in process before that snapshot is created. So the snapshot is created of a quiet volume, and then we back up the snapshot. The agent backs up the snapshot. At the end of the backup, the agent for Windows notifies VSS the backup did complete, and VSS is then responsible for deleting that snapshot. So in the job, in the definition for this backup, you need to be sure that you mark Advanced Open File and come down and mark the options for SQL. In the options for SQL, in this screenshot, we're looking at a one-time backup. In the options for SQL, I have several different options we're going to go through in detail later. The first one is to use checksum. This is a simplified database consistency check. It's a very simple, low overhead consistency check. The other option that you have is to create on-disk copies of the SQL backup. So this is creating a .bak file exactly the way that a DBA's script would create a BAK file. So if you are backing up a SQL database and you have a database administrator that would like the option of manually recovering that database, you can tell Backup Exec to write a BAK file, a database dump, to the directory that you provide here. The default location for the BAK file will be the same location as where the MDF file is installed. So we'll always drop the BAK file in the same directory as the MDF. So if I am backing up SQL 2005 or later, and I do a one-time backup, one of the options that I have under backup method is to use a snapshot, a database snapshot. This is a read-only point-in-time copy that then SQL will allow you to revert the database to that snapshot. There are several rules within SQL itself. This is if I take Backup Exec out of the picture for reverting databases to a snapshot. So it has to have had at least one full backup, and I cannot undo when I revert to the snapshot. Once you revert to the snapshot, it is what it is, and that database will be complete as it is. Backup Exec will delete all existing database snapshots except for the one being used to do the revert, to backdate the database. You cannot redirect database snapshot restores. Those must go back to the SQL server from which they were created. If SQL is encrypting the database, this is SQL itself. SQL supports TDE encryption. Backup Exec understands that. So TDE lets you encrypt the database at a backup set level. So not only is the database encrypted, the backups will be encrypted. Microsoft recommends that you also back up certificate keys and encryption keys when you back up the database. Again, with Backup Exec and the dynamic inclusion, if you back up the server at the highest level possible, Backup Exec will automatically detect if a new database has been added and if new certificate keys or encryption keys have been added, and it will just automatically back up everything that's related. When you're ready to back up your Microsoft SQL Server, there are several different strategies that are involved depending on how large this database is. We go back to the basic rule for all backups, that is, the longer the backup, the shorter the restore. So the more often you can run a full database backup, the more quickly you will be able to restore your server. So if you're a small environment, if it's a small database, it's best to run a full database backup daily or as often as possible. But in SQL, you must also back up the transaction logs. You have to touch both sides of the database in SQL, the database and the transaction log. Backup Exec will give you warnings if you forget to do one side or the other. So every backup definition that includes a SQL database should include at least 2 schedules, one for the full database backup and one for the transaction log backup. In mid-size or large environments, you may only have time to run a full database backup once a week. These can be very large databases, and these backups take an extremely long amount of time. So depending on how large the database is, again, the more often you can run a full, the easier it will be to do a restore. If I can only run a full once a week, or maybe even longer, I need to run transaction log backups as often as necessary, at a minimum daily. In extremely large environments, you may need to run transaction log backups every few hours or even hourly, because that's where all the changes are coming into the database. Remember that transaction log backups also commit those transactions to the database and truncate the transaction log. So they make the transaction logs more efficient. They make the database more efficient. So regular backups of the transaction logs will actually speed up database performance. So in large environments, you may need transaction logs hourly or every few hours, but I'm going to have 3 schedules in my backup definition. I'd have to have one for the weekly full, one for the transaction log, and one for a daily differential against the database. Again, I must touch both sides of this. If I commit changes from the transaction log to the database, I must also back up those changes in the database itself. The scheduling is the key here, and how often these backups need to run. Some of the SQL strategy for running backups. That you protect the entire SQL server using simplified disaster recovery. So I can very quickly bring that machine back. If it's also a physical box and you have enabled SDR, you could convert that to a virtual machine for a disaster recovery scenario. You may not want to run SQL virtualized indefinitely because it slows down, but I could bring it back up and get myself back up and running very quickly. Whenever you upgrade SQL, if you patch SQL, you need to run full database backups both before and after you upgrade or patch. You should run consistency checks before the backup. This one is going to depend on the people involved with SQL in your environment. Often, database administrators are very hesitant to let backup software back up the database. Historically, backup software wasn't always kind to databases and could corrupt the database during backup. So database administrators tend to be very protective and not allow you to run regular backups. If you can talk them into using Backup Exec to back it up, often if anything happens to the database, they'll come to the backup administrator and say, I told you that this backup was going to corrupt my SQL database. So often, backup administrators will run consistency checks after the backup finishes, so that if the DBA were to come to the backup exec administrator and say, your backup corrupted my database, the administrator could point to the job log and say, but I ran a database consistency check when the backup completed and all was well. So while backup exec and semantic recommend that you run consistency checks before the backup, because it doesn't make any sense to back up a corrupt database, often for ease of working together reasons, it makes more sense to run the consistency check after the backup. Could you run the consistency check on both ends? And the answer is yes, you could. However, that adds a great deal of overhead in CPU and memory usage to the SQL Server and adds a great deal of time to the amount of time it takes to run that backup. So typically you'll only run a database consistency check at one end or the other. There are various types of consistency checks. Some are easier on the SQL Server and faster to perform than others. So you could run a very fast consistency check before, and if your DBA was hesitant to let backup exec back up SQL, run the more involved consistency check after. Do what works in your environment. Back up the system databases regularly. This is master, model, and MSDB. Back up these system databases regularly. Master can only be backed up as a full. So if I have selected the entire SQL Server and I have told it to do differential backups against the SQL database, master will still be backed up as a full. Only run one backup at a time. You shouldn't have multiple backups running against that SQL Server at the same time. These cause a lot of CPU and memory usage. If SQL is configured for the full recovery model, this is the most detailed recovery of SQL. You'll need to back up the transaction logs separately. SQL can also be set in simple recovery mode, which essentially limits the number of transactions that can occur in the transaction log. If the server is set to simple recovery, then you only need to back up the database. You don't need to back up the transaction logs. So the different database backup methods, this is for the database itself. This is not taking into account the transaction logs. Against the database, I can do full backups. System databases like master can only be backed up as full. I can also do differential backups. A differential backup only backs up the changes, the deltas, that have occurred in that database since the last full. What caused things to change in the database was something happened to the transaction log. But a differential backup is only touching the database. It's not touching the transaction log. But it is the result of a transaction log backup having occurred at some point in time. So if you do a transaction log backup, you must also do a differential or a full. SQL also allows you to do full copy only backups which do not reset anything. They do not reset the transaction log. So they're similar to a full, but they don't affect future backups. So you can do them, say, at the end of the month, even though the end of the month is in the middle of the week, and they won't disrupt your regular backup methodology. I must also do backups against mirrored databases. So if the database is being mirrored from one location to another, then the backup exec SQL agent supports backing up those mirrored databases. I cannot backup or restore if the mirror is running at the time. So I cannot restore the primary SQL database while it's configured to be mirrored. I can restore the secondary, but I can't restore the primary while it is replicating. I can back up the primary and the transaction logs only if it does not leave the database in a non-recovered state. So if I need to leave the database in a non-recovered state, I need to do that with the mirror or the secondary database. I must also deal with the transaction logs. Now this depends on how SQL is configured. If it is configured for full recovery model, then the transaction logs will continue to grow and grow and grow until you run a backup. And running a backup is the only way to commit those transactions to the database and truncate or delete the transactions in the transaction log. So if I use a log backup, then I am backing up only the transaction log itself, not the database. I am committing those transactions to the database, and then I am truncating the transaction log. So if I run a log backup, I need to run it first and then run another backup against the database that is either a differential or a full. If you have run full backups against the database for 10 times and you have not backed up the transaction logs, Backup Exec will pop an error to you that says you must touch both sides of this, that you must also back up the transaction logs. Windows will also let you know because the transaction logs will continue to grow and grow and grow until that drive is full until you back it up. The log no truncate method is similar to doing a differential against a file system. There is no resetting of the transaction log, but it is only available in a one-time backup. So I'm backing up the transaction log as it is. I'm not going to reset anything, but that's all I'm doing is backing up the transaction log. If you're going to back up the transaction log, you should also back up the database as a whole. Usually this is done for purposes of full recovery or moving the database from one location to another. Consistency checks for SQL will depend on how busy that SQL server is. Backup Exec supports all the various consistency checks that SQL supports, and it will report back to you in the job log if there were any problems with the consistency check. Semantic strongly recommends that you run a consistency check before the backup. You can pick one of the versions of a consistency check that is not very intrusive, but it does you no good to back up a corrupt database, and a consistency check will let you know that the database is in good shape. So the consistency check uses the regular SQL utilities. This is all the API calls. So there's no difference between how Backup Exec accesses that database and how a DBA script would access the database. So the SQL utilities that you see listed here are exactly the same utilities that Backup Exec uses and that the DBA uses. So let's take a look at actually creating this backup definition for SQL. So anytime that you are doing VSS aware backups, that VSS can create snapshots, those backups should be written to disk. If you write those backups to tape, you'll be required to stage them on the restore side. So best practice is to always back up SQL to a disk location, and if you want to store it on tape for longer term storage, duplicate that backup off to tape. So let's start with a backup to disk. And if I'm going to do a one-time backup, it will also be to disk. And Backup Exec will show you the SQL server. It will show you all the volumes. but you'll see the little SQL database icon, the little drum icon. Ideally, these backups should be simplified disaster recovery enabled, meaning that the little green light is on. So you're backing up system state and the C drive in addition to all of the SQL databases. If you want to edit the selections, you'll come in and you can see the various pieces that are being backed up. This agent, the SQL agent, is really only concerned with the SQL Server instances. The agent for Windows is what is getting the C and the E drives. You should select this server at the highest level possible. I can just back up the SQL databases themselves and exclude everything else. In that case, you would need to run a separate backup to be able to do simplified disaster recovery of that server. You can also edit the schedule by which you are backing up the server. So in SQL, you should have at least, depends on how SQL is configured, but I should at least have a full backup. And if you're doing incremental, it means that I'm touching the transaction logs. So how do I want to back up the transaction logs? In this set of schedules, you can also set how you want to do consistency checks. In the screenshot that we see here, we're doing a physical check only. That is the least intrusive on the SQL Server. You'll notice that we're doing it before the backup. You could also do consistency checks after the backup. When I tell Backup Exec to do an incremental backup against SQL, what we're talking about is changes. So there I should have, in many cases, I should have at least 2 incremental backups. One that touches the transaction log and one that touches the database. The log method is going to commit all of the changes from the transaction log to the database and truncate the transaction log. You'll notice on the screenshot that we have here the note that says that databases that have a combination of log and differential, you must also do fulls. And Backup Exec will let you know if you're only doing fulls that you've not touched the transaction log and that you should also do an incremental against the transaction log. One-time backup, I can touch the database, which is a full backup, or I can do snapshots, or this is the only place that you're allowed to do log no truncate, which back up only the transaction log and do not touch the database. So that option is available only in the one-time backup. Let's take a look now at restoring a Microsoft SQL Server database. If we take Backup Exec out of the picture, SQL itself has several different methodologies for configuring SQL that impact how you recover your SQL databases. Full is the most complicated, but it is also the most detailed. A full recovery model is where I have a complete transaction log and I can roll the database or the transaction logs forward or back to a named transaction or a specific point in time. So every transaction in the transaction log has a date and time stamp. This ensures that no data is lost, and it gives me a tremendous amount of versatility in being able to recover either the transaction log or the database. A simple recovery model allows SQL to make minimal use of the transaction log, and this is appropriate for smaller databases. SharePoint is a great example here. SharePoint does not make heavy use of its SQL databases. So a simple recovery model says that I can only have a specific number of transactions in the transaction log. And once that number is reached, any new transaction coming in, the oldest transaction will automatically be committed to the database, and so the transaction log stays very small. Backup Exec understands this and knows that in this case, you don't have to deal very much with that transaction log. Bulk logged is another SQL configuration that allows me to recover the database to the end of any backup, but if there were transactions in the transaction log that ran after the backup, you would lose those transactions. So you would have to re-enter anything that was in that transaction log that occurred after the backup and after the restore. SQL itself also lets you revert a database to a snapshot. That is a point in time. It's a picture. I took a picture of the database yesterday at 4 p.m. If I'm going to revert to that snapshot, I'm going to revert to what it was yesterday at 4 p.m. Anything else will be gone, and I don't have to run a full restore. I'm simply reverting the database to that point in time snapshot. Backup Exec understands all of these recovery models and supports each one of them. So the Backup Exec recovery models for SQL are that we will allow you to restore the database itself to the date of the last backup. We will allow you to restore the transaction logs to a point in time or a named transaction. This is actually easier in Backup Exec than it is in SQL Recovery Manager. So I can recover the transaction log to a specific point in time very easily in Backup Exec. And many DBAs, many database administrators appreciate that functionality of Backup Exec and will allow you to back up their database because of that functionality. I can also restore master, the master database, which allows you to then restore any databases under it, but I can restore master and leave my production databases alone if master got corrupt. I can also revert databases to a snapshot. Backup Exec supports that same functionality that you see in SQL. When I tell Backup Exec to do a restore, you must tell it that you're restoring SQL data as opposed to files and folders. Backup Exec, if you have the SQL agent, will not expose the SQL files to you directly. It must always go through the database agent. When I drill down into my restore job, I can select which databases must be restored. If you select a database that is a production database, in the screenshot that we have here, it's BEDB, Backup Exec will automatically restore master along with that and automate that process. I can tell the restore side to which backup I wish to restore. So the default is to the latest backup, but you'll notice the third radio button down here is to restore the transaction log to a specified time. So this is the roll forward or roll back that SQL supports in the transaction log if you're in a full recovery model. This option will not be allowed if you were in a simple recovery model, and that's more a function of how SQL was configured. I can also restore to a named transaction in the transaction log, or I can restore to an individual backup that you selected. This one is important if you had corruption hit the database today and I'd run a backup, but I really want to restore it to yesterday. Backup Exec by default always wants to restore the latest, and you have to tell it that you want to override that. I really want to restore one that's a day or so old, understanding that I will have to redo anything that happened since that backup. So you select the point in time to which you want to restore. If the point in time is reached, then you can't recover anything else from that transaction log. Backup Exec will log for you in the job history what's happened. And so we support all the standard SQL roll forward, roll back rules that apply. The database administrator should understand these rules. You can also restore to a named transaction. And it will also apply the date and timestamps that existed with those named transactions. I can restore to the same location from which the database was backed up, or I can redirect. If you want to redirect SQL databases, SQL itself, the application, must be installed on the server to which you are redirecting. So if I backed up my SQL databases from old hardware, on new hardware I have to have Windows and SQL and the agent for Backup Exec installed, and I can back up those databases and redirect them to the new hardware. But SQL has to exist. You have to have a parking lot to park the car in. How do you want it to restore if the databases already exist? Do I want to take the databases offline before starting the restore? This is a best practice, but it means that your users will not be able to access the database. It is also a best practice anytime you do a restore to do a full consistency check after the restore has completed. That way you make sure that what you restored is fully functional and ready to go. You can also tell it to continue if there are errors. By default, on the restore side, Backup Exec is just going to send all the restores required to the point in time that you said. So, if I had been running a full backup every Friday, transaction log backups every night during the week, and differential backups every night during the week, and my server dies on Thursday, I tell Backup Exec to restore to Thursday. Backup Exec is going to totally automate the process of restoring the full, all the differentials, and all the transaction logs backups in the correct order. You do not have to know which backups are being restored in which order and send them yourself. Backup Exec will totally automate that process for you as a result of having it backed up all as a single job definition. So I can tell it to continue if there are errors and run database consistency checks as needed. What state would you like to leave the database in when the restore completes? So it would run the database consistency check and bring the database back online where users could access it. It will ask you, when do you want this restore to run, and give you a summary, and then you'll see the restore run. It may also automate the restore of the master database depending on what you told it to restore. I can also redirect SQL. SQL databases are typically tied to the host name of the SQL server, and SQL doesn't always allow redirects. Backup Exec helps you with this. So I can do single database restores, I can do multiple database restores, and redirect all of that as needed. So I could back up the database from a 32-bit platform and restore it to a 64-bit platform. So in this lesson, we have talked about the components of SQL, the functionality of SQL, how SQL expects to be backed up and restored, and the capabilities of the Backup Exec agent for Microsoft SQL to support all of the SQL scenarios for backup and restore. And we've talked about how to create the backup job to back up SQL as efficiently as possible, and how to restore SQL, and then also how to redirect SQL databases.